Today we'll see about that recursions. Okay. So generally recursion is nothing but a function that is to be defined. A function that calls itself is called as a recursive. The name itself specifies that the function that calls itself is called recursive. Okay. So instead of doing that entire program into large, so we are iteratively, repetitively calling that same function. Okay. And we are passing parameters to that function to solve such examples. Okay. A simple example here I will tell you. Okay. For example, I need to be calculate one of the scenario. For example, I need to be calculate 4 factorial. Generally, when you are going to be calculating a 4 factorial, so how we are calculating? So simply 4 into 3 into 2 into 1. But this is replaced as 4 into 3 factorial, which we are calling. So what is meant by 3 factorial? 3 into 2 factorial. What is meant by 2 factorial? 2 into 1 factorial. So like that we are calling. Okay. The factorial of a given number. Okay. Whether the number is, okay. Whether the number is 5 or 4 or 10 or 20, whatever it may be. This is generally you are calculating that procedure. Okay. This is the way of we are solving that factorial of a given number. For example, if I given number is called suppose 10 factorial. So how you are calculating 10 into 9 factorial you are calling. Okay. How we are calling that 9 factorial? 9 into 8 factorial. Okay. How we are calling 8 factorial? 8 into 7 factorial. Okay. If it is a 7, 7 into 6 factorial. If it is a 6, 6 into 5 factorial. So like that you are repetitively executing. After that, so now we are after the multiplication of each and every value, that is nothing but 4 into 3 into 2, you are getting that 4 factorial. So here also we have. So 10 into 9 into 8 into 7 into 6 like that. Okay. So that is always equal to the given factorial of a, I mean the factorial of a given number. Okay. So to do this procedure, simply how we can write, how we can call a function itself recursively or iteratively. Okay. So for example, see here, how we can write the program. So see here. So here I'm taking that new file. Already I have taken new file. So here I'm taking that main method. Okay. So in this main method, I'm asking the user to provide. So I would like to save this program with recursion. Okay. Now see here. So now I'm asking the user to provide the number from keyboard. So which number you are going to be planning to find the factorial. Okay. So for that here I taken that a number called n. Now I'm asking the user to provide that number. Printf, enter the fact, enter the number to find the factorial. Okay. So to read that number, we can use that inbuilt function scanf %d. To read any value from the keyboard, we can use that ampersand of n. Okay. So now, so whatever the number the user is entered, that number is taken as a parameter. Okay. Now I am passing this n as a function to that. Okay. So here I am writing that one of the function called factorial. For that factorial, n is passed as a parameter. Okay. What is the function I call factorial? So it takes only one argument. What is the argument? As a user, whatever the number that we entered, that is passed as a parameter to this factorial. So now here I am writing the factorial. Okay. Right. Okay. So here I'm taking that whether you are taking that return type or non-return type. Okay. Suppose I would like I'm passing that some return type. Okay. Factorial. So because I need to be give the results to that once again to that main method. So that's why. Okay. Factorial. So here I've taken that num. What is the actual parameter? Actual parameter is n. Formal parameter here I treated as num. I need to be recall. So actually, suppose during the runtime environment, if I given number is n, so 4 is passed as a parameter. When the call is occurred, then control goes to here. Now num is treated as a 4. Now we need to be calculate that 4 into 3 factorial. Okay. To do that one, so here 4 into 3, you need to do that one. So num, whatever the num that you have, that is num is multiplied with factorial of, once again I'm repetitively calling that factorial of which number you are calling, which number you are planning to call, 3. You are planning to call 3. So how we can get 3? So actually num is a 4, 4 into 3. How we can get 3? So that is nothing but num minus 1. So here we need to be called num minus 1. Num minus 1. Okay. Now we represented. So 4 into, so num minus 1. What is a num minus 1? That is a 4 minus 1. That means that 3 factorial you are calling. So once again it will call. Okay. So what it calls, 3 into factorial of 3 minus 1. 2 factorial will. Once again 2 will be called. Okay. 2 into 2 minus 1. 1 factorial. Once again it will call. 1 into 1 minus 1, 0. So but how many number of times you need to be do this procedure? So generally 4 factorial is nothing but 4 into 3 into 2 into 1. Up to you need to be calculate the factorial. Once if reach that number is reached the 1, you need to be stop that procedure. Okay. Once if you reach the number is 1, you need to be stop. Suppose if you are decremented 1 in, so next number 0. If 0 is multiplied, everything is 0. So you need to be stop. Okay. Some particular value. So that particular value in the recursion, we can call it as a base case. Okay. So this base case will give the information of, this base case will give the information of when I need to be stop that procedure. Repetitively calling the same function when I need to be stopped. Okay. To stop the procedure, here we represent some condition. So what is that condition? When the number is reaching to the 1, you need to be stop it. When the number is reaching the 1, you need to be stop that procedure. Okay. So in that case, for that purpose, here what I am doing is, okay, here, please be silent, mute yourself. So whenever the number is, okay, so now you need to be check that if the num is, if the num is exactly 1, then you need to be stop it. Okay. Otherwise, you need to be do the same procedure. Suppose if that condition is failed, in the else case, you need to be right that num is multiplied with factorial of num minus 1. So you repeatedly you are calling the same function. Okay. Once and I'm repeating the same program. Okay. See here. So now here we pass that num is called 4. Okay, through the keyboard. Now factorial of 4 we are calling. When the call is occurred, the called function definition, num is treated as 4. Is 4 is exactly 1? No, condition failed. So if that condition is failed, then you are calculating that 4 into factorial of, you are calling that factorial of 3 you are calling. What is the parameter that we passed? Num minus 1, 4 minus 1, 3. So once again, re-execute the same function. What is that? Now what is the number? Now the number is 3. Now once again checking that is 3 is exactly equivalent to 1? No. So that means that condition failed. Control goes to the else case. In the else case, what you have written? Num into factorial of num minus 1. What is the num value? So presently 3. So 3 into factorial of 3 minus 1 means 2. So now the parameter passed to that function is 2. Once again, recalling the same function. Now the num is 2. Once again checking that 2 is equivalent to 1. Condition fail. Once that condition is failed, then control goes to the else block. In the else block, what we call num into factorial of num minus 1. What is the present num? 2. 2 into factorial of 1 minus 1. 2 minus 1 means 1. Okay. So now it is 2 2. When it is exactly one case, you need to be stopped. So for that purpose, okay, so I need to be written 1. Okay. Already I have written that parameter called, okay, the data type for that function here I've written as int. Okay, simply I need to return 1. Else case, if that condition is failed case, so here I need to be written num into factorial of num minus 1. Okay, so now this value will comes to where Now this value will comes to the main method. So in the main method, here we called. Okay, after the completion of, then it immediately calls. Okay, so that means that so once again, final statements, final explanation I'm giving. Okay, now see here. So here we pass that. So n value is called, assume that 5. So 5 is passed. Okay, so num is, now it is a y 5. Okay, is 5 equivalent to 1? Now condition fail. You are returning that. Which value you are going to be returning to that main method? Okay, you are returning that to the main method. So here you are returning. So what is the value that you are returning? 5 into factorial of 5 into 5 multiplied with factorial of 5 minus 1. 4 you are calling. So once the call is occurred, once again control base the calling function. Okay. So in the called function, now num is treated as 4. Is 4 equivalent to 1? Now fail, else case it will execute. That is nothing but, so this will be executed as 4 into factorial of 3 will be called. 4 minus 1, 3. Once again, the parameter is 3. The control goes to the, once again, now instead of num, now the num is called 3. Now checking that is 3 is exactly equivalent to 1. Now condition fail. Once again, else block will be executed. In the else block, what here written? Num into factorial. So what is the num value presently? 3. 3 into factorial of 3 minus 1. That is nothing but factorial of 2 will be called. Okay. So once again, control goes to that called function. Now the num is called 2. Okay. Now we can check that is 2 is exactly equivalent to 1. Now condition fail. Once again, it will call. So 2 into 1. This entire function will be called 2 into 1. Okay. When the num is 1, you need to be written. So in here, you need to be written as well. So once if it is written 1, so 2 into 1, 2. So once again, what is the previous step that we have? 3 into 2. So what is the previous step that we have? 3 into 2. So that is nothing but 6 we have. So this 6 will be multiplied for this one. 4 into 6. That is nothing but 24. So this value will be given for this. Okay, back to that previous statement. So 24 into 5. What is the value? We will get. So that is nothing but 120. We will get 120 as a result. This 120 will be returned to your main method. Here we are going to be stored in another variable and we need to be print that factor. Okay. So here we need to be written. Okay. So for that purpose, here I am using, either you can store in another variable or directly you can pass to the print function, printf. Okay. So here I'm using the %d. Okay. And then comma and whatever the parameter that we have passed. Okay. So simple purpose here I'm trying to print that n factorial is, okay. Suppose if you want that number, then %d factorial equal. So I need to be print the 10 followed by factorial of that number. So I'm trying to be printing two numbers. For example, if n is given as 5, so 5 will be printed. 5 after that factorial, that is nothing but a exclamation mark and equal, and 5 factorial value we can get it. This 5 factorial value we can get from this function. Okay, so this value written from that main method. This value we can get from that main method. Okay, so now I would like to save this program and executing that program. Okay. So here we are providing that number. Here we are providing that number 5. Then check it. So 5 factorial 120. The function that calls repetitively same function. So here what is the function name that we use? Here what is the function name that we use? Factorial. The same function that repetitively, if you are calling to the function that calls itself is called recursion. Okay, see the definition. See the definition. The function that calls the function, it is defined as a function that calls itself to solve a smaller version. So the function that calls itself, whatever the function that you have written, the function is calling that same function name. Once again, it is called recursion. Here we are representing majorly two cases. Okay, so one is called base case, second one is recursive case. So what is the base case here? Here this is the base case when you need to be stop that procedure. Okay, this is called base case. Okay, so this is called base case. This is called recursive case. What is the meaning of base case? What is the meaning of recursive case? So here I'm explaining with the explanations here. So in the whatever the problem that you are solving, okay, so you are going to be stopped on a particular case without no further improvement or further updating of that value. So that is called base case. So that means that you need to be stopped enough to solve. Okay. So you need to be do that factorial up to when n is reached to 1 only. Okay. For example, 3 factor you are calculating, that is nothing but 3 into 2 into 1. Okay. So now 3 into 2 into 1 into 0 into minus 1 into minus 2 into like that. So if any number is multiplied with 0, then everything is 0. So in the factorial calculation, you don't need to do. So up to when it reaches to the 1. If number is reached to 1, that is enough. That is enough to stop that calculation. Okay. So in that case, here we will use this point. Okay. So this is one of the base case. And what about the recursive case? The recursive case tells about that in which the problem at, okay. So now we are furtherly divided into subparts. Now we are divide that entire program into subparts. In the first part, second part, third part, like that. Okay. So what you have done in the initial case, we are calculating that 5 factorial. Okay. First you are defined that 5 into factorial of 5 minus 1. So this is a subpart. Okay. So what about the factor 4 tells about that 4 into factor of 3. What about the factor of 3? We'll talk about 3 into factor of 2 you are calling. What about factorial of 2 telling 2 into factorial of 1? Okay. So now you are divided that entire program. This is the first part and this is the second part. This is the third part. This is the fourth part. Like that, the entire program is divided into subparts. And after the subpart, now you are going to merge all the parts. That is nothing but 5 into, what is the factor of 4 will call? The factor 4 is calling that 4 into 3. Okay, 4 into factor of 3. What about factor of 3 will calling 3 into factor of 2. 3 into factor of 2. What about factor of 2 is calling 2 into 1. 2 into 1. So now this is the final value. This final value will return to that main method. This is a recursive case. This is called recursive case. Okay. The function that it calls that itself, okay, calls each and every sub problem to obtain that first step. Okay. So if it is a first step is over, then second step is over, third step. So unless if you reach to that base case, you are repetitively executing. Unless if you reach to that base case, you are repetitively executing the task and we are calculating that factorial of a given number. Okay. So in this calculation here, we are not using that any looping technique. Simply we have the function that calls itself is called recursive. This is one of the example. Okay. So this is a sample example code. Here, what is the base case here? What is the base case here? So this is the base case. The condition when you need to be stopped. This is the base case. Okay. So this is called a recursive case. This is called recursive case. Okay. So this is a simple example related to the factorial of a given number. Okay. Factorial of a given number. For example, I need to be calculate another example. We can write another recursion function to calculate the sum of n natural numbers. Okay. For example, simply I am taking that another file. Okay. So sum of n natural numbers. Okay. Simply I'm taking that I would like to say this program with sum of n recursion. Okay. Yeah. So simply I'm taking that main method. Okay. So to find that sum of n natural numbers. Okay. For example, if I given simple example, if I given a number called 6, now you need to be calculate 6 plus 5 plus 4 plus 3 plus 2 plus 1, you need to be calculated. How we can do this process? Okay. Okay. How we can do 6 natural number sum? How we can do this process? Okay. With the recursions. So for that, here I'm taking that a number as usual, and I'm asking the user to provide that number from the keyboard. Enter the number. To read any number from the keyboard, then here we need to use that scanf %d. Okay, read that number from keyboard. So n is a number. I already told to you, please be in mute. Here I've taken a number from keyboard. Okay, to find the sum of n natural numbers, here I'm repetitively calling that function called sum. Sum is my function, and I'm repetitively or recursively calling that uh, 6 to up to 1. Okay, whenever the call is occurred, then function control goes to that. Okay, so here I'm calling that I would like to return the value to the main method. That's why I'm using that integer is a return parameter. Okay, so here I'm passing that num is a parameter to that sum function. Okay, so actual argument is n, formal argument here I treated as num. Up to, you need to be add the numbers up to when n is reached to that 1. So for that, here I'm applying a condition. If num is exactly 1, then the value need to be written as 1. Okay, else case, if that in else case, okay, in else case, here you need to be calculate the sum. So what you need to be calculate the sum, return the num that is plus with, that is num added with. Okay, when you are going to be calculate that n natural number, so first you need to be return that 6 plus, okay, sum of 5 you need to be calling. So sum of 5 you are calling. Okay, so for that purpose, here what is the function name? Sum. The function that calls itself, I need to be get 5. Okay, already number I have given as 6. So when I need to be get 5, sum minus 1, num minus 1. Okay, 6 is 6 minus 1, 5. Once again, what is the parameter that we pass? 5 is passed as a parameter to that. 5 is passed as a parameter to this function. Now 5. Once again, call is occurred. Then once again, it will recursively call. Okay, it check that is num is equal to 5. 5 is equivalent to 1. No. Then else case will be executed. Then it will call that return of num plus sum of 5 minus 1. So that is nothing but 5 plus sum of 5 minus 1. What is the 5 minus 1? 4. Once again, it will be called repetitively. Okay. Is 4 equivalent to 1? No. Else case, it will call that 4 plus sum of 4 minus 1. 3. Once again, it will be repetitively called. Okay. So now the number is 3. 3 equivalent to 1? No. Failed case. It will go to the else case. In the else case, what you are writing? Num plus sum of num minus 1. What is the num value? 3. 3 plus sum of 3 minus 1. You are calling that sum of 2. Once again, repetitively calling. Num equivalent to 2. Is 2 equivalent to 1? No, failed case. It will call 2 plus sum of 1. It will be called. Once again, repetitively call. What is the num value? 1. Is 1 equivalent to 1? Yes. Now it returns the 1. So now this function will return 1. So now 1 plus 2, that is nothing but 3. 3 plus 3. So it will, the step will forward get back 3 plus 3. So you can get 6. So that value is added with 4. That value is added with 5. That value is added with original number 6. Okay. So then you can get a natural number sum without doing any, without considering any looping technique. Here we calculate it. Okay. So like that, the function sum that itself call that same function, that is called recursion. That is called recursion. Now, so after that recursion completion, then what we need to do? So you need to be print that result. Where you need to be, the value will be returned to that main method. So in the main method, here I'm printing that printf. Okay. So the sum is the sum of n natural numbers. What is n? So whatever value that I have given from the keyboard, %d sum numbers is, okay. So I would like to print that result also. Okay. So n I would like to print, and then sum also I need to be printed. I'm trying to print that n and then followed by n natural number sum. So after that function completion, close the parenthesis and then put the semicolon. Okay. So this is the sample fragment of code. Okay. So we will execute this fragment of code. Okay. Suppose if I given the sum is number is called 6. So what is the summation of 6? This is 6 plus 5. So what is the value? 6 plus 5. What are the values we can get it? Okay. So 6 plus 5, 11. 11 plus 4, 15. 15 plus 3, 18. 18 plus 2, 20. 20 plus 1, 21. So the result is 21 will get it. Suppose if I given the number is called 6, now we can see the answer. We will get the answer called 21. So like that, we can write the recursive function. Same natural numbers summation. Okay. This is a sample example. Okay. This is a sample example. This is a fragment of code and how it is to be executed. So on the screen I written. Okay. So this is the way of executing that n natural number sum using recursion. Okay. For example, so I will go with another example also. Okay. I need to be identify the reverse of a given number. Reverse of a given number using recursion. Okay. So now what is meant by reverse of a given number? Suppose if I given a number called 523. Okay, what is the reverse of the given number? 325. How you are doing this 523 into 325? So how you are calculating that reverse? So we are taking that initially 523. Okay, this is the number you have. So initially you are taking that reverse is initially 0. Okay, initially 0. So now you are calculating that unit digit in this number. To get that unit digit number, you are using that modulus operator. This is called remainder. Okay, so now you are obtaining that remainder value called 3. Okay, so now your number is updated with 520, whatever the number that you have, that is multiply, I mean divisible by 10. So that means that you are getting that coefficient value, that is 52. Now the reverse is, so what is the previous reverse is multiplied with 10 into present remainder. Okay, so what is the previous reverse value? 0. 0 into 10 plus what is the present remainder? We are getting 3. Okay, 0 into 10 plus 3, that is nothing but 3. Now repeat that loop until that num is not equivalent to 0. In the next iteration, so this num is not equivalent to 0. So now you need to be use the looping technique. While num not equivalent to 0, you need to be do all these 3 steps. Okay, now what is the number? 52. Is 52 is not equivalent to 0? Yes, condition true. Now once again you are calculating the remainder. 52 mod of 10. If 52 mod of 10 means you are getting the 2. Now what is the remainder value? 2. Now what about the num value? If 52 is divisible by 10, what is the quotient value? 5 we are getting. Okay. So when you are going to be talking about reverse value, okay, reverse is nothing but reverse value. What is the previous reverse value? 3. 3 into. So 3 into 10 plus what is the remainder value? 2. 3 into 10, 30. 30 plus 2. So 32 we are getting. Okay. So 32 getting. So what is the num value? 5. Okay. Now repeat that loop once again. Okay. So in that repetition, is 5 not equivalent to 0? Now we are checking that num not equivalent to 0. What is the num value? 5. Yes, 5 not equivalent to 0. Yes, that condition is true. Once again, we are calculating that modulus value, remainder value. So 5 mod of 10 you are doing. So 5 mod of 10 is nothing, 5 only. Okay. 5 divisible by 10. What is the quotient value? 0 we are getting. Okay. Now what about the reverse value? Reverse is calculated as reverse into 10. What is the reverse value? Previous reverse value? 32. 32 into 10 plus what about the remainder value? 5. So that is nothing but 32 into 10. So that is a 320. 320 plus 5, 325. We are getting. Actually, what is the value we have given? 523. If it is reverse, 325. So that's your answer. That's your answer. Here, if you observe that repetitively we are doing the same process repetitively we are okay, until the number is not equivalent to 0 case, we are repetitively re-executing. Actually, this is the logic. Now we need to be do the same process. Okay, so you need to be do the same process. So up to the given you need to be do this process and up to the number is not equivalent to 0. Suppose if it is equivalent to 0, what it needs, you need to be written that reverse value. You need to be written that reverse value. Okay. Is it clear? So now for this purpose, Okay, so now here, okay, this is a way of executing. So now I'm doing the same process. Now initially I've taken a main method. Okay, I'm asking the user to provide the number from keyboard. Already we have written the code. So to read any number from keyboard, this is the technique. So instead of rewriting, I'm using the same steps. Okay, now I'm asking the user to provide the number from keyboard. Once the number was provided from the keyboard, now I'm asking that. So here I'm calling that one of the function called reverse. So instead of taking one parameter, I will pass one or more number of parameters. Yes, you can pass one or more parameters. Okay. Now here I'm passing the two parameters. One is n. So another one is fixed value. I'm going to be repeat because why I am passing that parameter means 0. So initially, what is the reverse value you have taken? So initially, what is the reverse value you have taken? This is the reverse value you have initially taken. That reverse 0 is passed as a parameter to this function. Okay. Okay. Now I'm passing that. Now I'm passing that 0 is parameter to that reverse function. So initially. Okay. Now after that, whenever the call is occurred, then control goes to that calling function. Okay. Now here I'm calling that I need to return the value to the okay to the main method. So that's why I'm calling that integer is a return parameter, and what is the function name? Reverse. So here I'm passing that num is a one parameter and another value called for example reverse value. So what is the initially reverse value? I taken as 0. So that 0 is passed as a parameter to this function. So actual argument is nothing but n comma 0. Formal arguments are num and rev reverse. So now this 0 will be allocated to reverse. Okay. Now you need to be check that. So now I'm checking that how to do that process. If the num is exactly 0 case, now you need to be stop it. Okay. Now you need to be stop it. Otherwise you need to be do the procedure. Okay. So for that purpose here I'm using it return. So whatever the value that we have, that value I'm going to be returning. Else case. So I need to be returning. I'm planning to return. Okay. So each and every time I need to be do the same procedure. I need to be pass iteratively. So for that I'm passing the parameters, two parameters I need to be passed. One is the quotient value. Another one is the remainder value. Okay, that remainder is multiplied with the original value. So for that purpose, so reverse of okay, reverse of to get that quotient value num divisible by 10. Okay, how we can get the reverse value? So previous reverse into multiplied with 10 plus remainder. What is the remainder that we can get it? So using num mod 10. Okay, so same here technique here I'm applying. Num mod 10 is nothing but the number mod of 10 is nothing but remainder. So that is multiplied with 10. Okay, that is passed as a parameter. So I'm planning to do like that. Okay, whatever the value that we are getting. Now here I'm trying to print that value. Printf. Okay, so what is the value? The reverse of the given number. So given number is nothing but n. So that is a percentage d is percentage d. I need to print two values. So one is n I'm printing and another is reverse of the given number. So both I'm trying to printing. Okay. So now I would like to say this program. Okay. So this is a reverse of a number. So giving the values rev recursion. Okay. So now I have written the code like this. I'm planning to execute this code. So now I given that 523. Now if it is converted 325. Okay. So whatever the process that we are calling, what is the function that we call reverse? The function that calls itself. Okay. So here we are passing that iteratively reverse iteratively. So how many parameters we passing? Two parameters. Initially we are passing that n comma 0 in the iterative call. Okay, quotient value and then whatever the reverse that we are getting. Suppose if the num is reached to 1, then we need to stop that procedure and whatever the reverse value that we have, that you need to be return to that main method. And in the main method, you are printing that the reverse of the given number. Okay, this is another example using recursions. Previously, we have seen factorial, sum of n numbers, reverse of a given number we have seen. Okay. Or suppose, say another example, if you're going to talk about another example, okay, using recursions. Most of the times we are writing that one more method, one of the example called Fibonacci series. How we are calculating that Fibonacci series? So generally Fibonacci series is written as, for example, I need to identify that print that first five Fibonacci numbers. First two Fibonacci numbers we are treating that 0, 1, 1. So these are the first two Fibonacci numbers. So that means that, so for example, first two Fibonacci numbers are 0 and 1. The summation of these two numbers, we are getting the next Fibonacci number 1. These two numbers summation, we are getting that next Fibonacci number. These two Fibonacci numbers, we are getting that next Fibonacci number 3. So next Fibonacci number, we are getting that 5. So like that. So the addition of these, we will get. The addition of these, we will get this. The addition of these, we will get this one. The addition of these, we will get this one. So this is the Fibonacci logic. Okay. So how we can do this process? Okay, how we can generate Fibonacci numbers using recursions. Okay, so for that purpose here, okay, the main same program, how many Fibonacci numbers you need for that purpose, I am taking that main method, okay, with 10 Fibonacci numbers generation. So simple. Okay, first I will say this code. Okay, so this is a relation, this is a program related to that Fibonacci recursion, fib res, okay, recursion.c. Okay, now see here. So here I'm taking the variable. I will take a function called a Fibonacci series. Okay, so for that purpose, here I'm taking one function called fib is a one function. Okay, for this fib function, here I'm passing n as a parameter. N is passed as a parameter. Okay, how many number of Fibonacci numbers you need? How many Fibonacci numbers you need? Each and every time you need to be repetitively add these two numbers and you need to be print. Add these two numbers and you need to be print. Add these two numbers, you need to be printed. Okay. So for each and every time you need to do the same procedure. For that purpose, here I'm using that some looping. Okay. Okay. For I equal to 0 and I less than n, I plus plus. So in each and every time I need to be repeat the same process. So what is that process? I need to be calculate this Fibonacci. Okay. Whose Fibonacci you want? The ith Fibonacci number I want. What is the first? I means 0. What is the 0th Fibonacci number? So 0th means initially 0. Okay. First Fibonacci number, second Fibonacci number, third Fibonacci number, fourth Fibonacci number. So like that. Okay. So I need to print those values. For that, here I'm using it printf. In the printf statement, here I'm writing. Okay. So printf %d. So whatever the number that you need, that number is separated by, if you want comma, so then put the comma. Okay. So ith Fibonacci number I am asking. Okay. So what is the I? Initially 0. What is the 0th Fibonacci number? 0 only. Okay. What is the first Fibonacci number? If you are going to talk about the Fibonacci numbers are like this. Okay. For example, you're going to be talking about 0, 1, 1, 2. If you treat this is the first Fibonacci number 1, second Fibonacci number 2, third Fibonacci number 1, fourth Fibonacci number 2. Suppose if you take this is the 0th Fibonacci number, this is the first Fibonacci number, this is the second Fibonacci number, this is the third Fibonacci number. So you can take the loop. If you are starting from the loop 0, so that means this is. If you are starting with the loop is 1, so in this case n plus 1 or n equal to 1. Either you can apply any condition, no issue. Okay, you can apply any condition. Okay, so now in all these cases, you need to be calculate the Fibonacci generation. Okay, so for that values are to be written to the main method. So that's why I have taken integer return parameter, and here I'm passing that. Okay, num is passing as a parameter to that function. Okay, now I'm checking that is that num is exactly 0 or not. Okay, if the num is 0, so you need to be written that first Fibonacci number is nothing but 0. Okay, else you need to be check. Okay, if num is exactly 1, so what is the second Fibonacci number? 1. Else, if that condition is failed, then you need to be generate. Okay, how we can get the next Fibonacci number? Okay, for example, See here. So this is a 0, this is a 1. Okay. So now I'm getting that first 0th Fibonacci number means 0. First Fibonacci number means 1. If it is the second Fibonacci number, how we can calculate? So 0 plus 1. 0 plus 1 calculated 1. Okay. Suppose third Fibonacci number, how we can get? First Fibonacci number, second Fibonacci number. What is the first Fibonacci? 1 plus 1, here get 2. Okay, next Fibonacci number 1 plus 2, 3 will get. Next Fibonacci number 2 plus 3, 5. Okay, so that means that series will be 0, 1, 1, 2, 3, 5, 8. Next 5 plus 8, 13, 13 plus 8, 21. Next 34. So like that we are generating. If it is nth Fibonacci number, so then how we are calculating the 10th Fibonacci number? This nth Fibonacci number is calculated as n minus 1 Fibonacci number and n minus 2 Fibonacci number summation. Okay. So n minus 1 Fibonacci number and n minus 2. N minus 1 Fibonacci number. So that is nothing but 21 plus n minus 2 Fibonacci number. What is n minus 2 Fibonacci number? This one. Okay. So n minus 1 means 21 plus n minus 2 is nothing but 13. 21 plus 13 is nothing but 34. That is your Fibonacci number 34. So that means that nth Fibonacci number is generated as n minus 1 Fibonacci number addition with n minus 2 Fibonacci number. Okay. How we are getting? For example, n is 5. How we can get 5? So what is a n? If n is a 5, what is n minus 1? 3. What is n minus 2? 2. So now n is represented as n minus 1 plus n minus 2. So that is nothing. N minus 1 value is 3. N minus 2 value is a 2. 3 plus 2, 5. That is your nth Fibonacci number generation. Okay. Now for this, so here I am recursively I am calling, okay, the same function fib of, okay, num minus 1, that is added with fib of num minus 2. Okay. Recursively, I am calling this. Okay. Fib of num minus 1 value plus fib of num minus 2 value, that will be added and will be returned to that main method. Okay. It will print on this in the main method only. Okay. So that's about the recursion of generating n Fibonacci numbers. Okay. So this is a sample fragment of code. I hope this entire source code is visible to you. Okay. Now simply run this fragment. So here we are getting an error. I is not declared. Now I'm defining the type. Okay. Now run it. I need 5 Fibonacci numbers. Okay. So for example, I need 5 Fibonacci numbers. Here I'm giving from the keyboard given as a 5. Then check it. These are the 5 Fibonacci numbers. 0, 1, 1, 2, 3. For example, I need 10 Fibonacci numbers. Now check here. 0 plus 1, next number 1, 1 plus 1, 2, next number 1 plus 2, 3, 2 plus 3, 5, 3 plus 5, 8, 5 plus 8, 13, 8 plus 13, 21, 21 plus 13, 24, 34. So like that we can get it, Fibonacci numbers. Okay. We will see, suppose if I am planning to print 20 Fibonacci, whether it is printing. So if it is out of the range, we will get some garbage values. So it is within the range only, because 36,000 integer range. We can get 10 Fibonacci numbers. Okay, using recursions. Okay, so this is a sample fragment of code that will explain, that will generating Fibonacci numbers using recursions. This is another example. So using recursion, the function that call itself is called recursion. We have seen factorial logic, sum of n natural numbers we have seen, reverse of a given number we have seen, Fibonacci numbers we have seen, and in another example, okay, if you're going to talk about recursion in terms of another example, most of the times we will use exponential cases. Okay, for example, I'm going to be calculate 2 power 3. So that is nothing but 2 into 2 into 2. Repetitively executing the same task. Okay, 5 power 6. How we are calculating? 5 into 5 and once again 5. That is multiplied up to 6 times you are multiplying. Or simply we can call exponential or power of a given number. Okay, if I have the base value and then okay, base value. So here this is called base. and this is called exponent or power. If you know these values, you can calculate the exponential, I mean, power of the given number using recursions. That is another example also. We will calculate using that one also. Okay. So these are the some examples. Suppose if you want this one, I will explain. Okay. For example, I need to be calculate power of a number. So that means that another example. Already I completed Fibonacci series. So now I'm moving to the another example. Power of a number. For example, taking that 5 power 6. Okay. So this is in the form of a power b. Okay. First you need to be read the value of a, read the value of b, because you need to be calculate what is the base value, what is the power value. Okay. So for that purpose, in the main method, okay, here I will take main method. So in this main method, I need to be read two numbers. Okay. One is a value, another one is b value. Okay. So for that purpose, here I'm defining two different variables. So integer a and then b. So a stands for base, b stands for power. Okay. Now I'm asking that user to provide those numbers. Printf, enter the base and power or exponent value. So you can call any name. Exponent value. I'm asking the user to provide these numbers. To read any number from the keyboard, here we'll use scanf. Two numbers I'm reading, percentage %d, percentage %d. So what are those numbers? A and then B. So these are passed as a parameter to that. I mean, these two values I'm trying to be reading from the keyboard. So when I'm trying to read any value from keyboard, you need to use ampersand. Scanf, percentage %a, ampersand A, ampersand B. Now I need to be calculate the power of value. So for that, so here I'm calling one of the function called power function. So it takes two parameters, A and B I'm passing as a parameters. Okay. How we are calculating this power of 5 power 6? Okay, simply 5 power 6 is calculated as 5 into 5 power 5. Once again, 5 power 5 is calculated as 5 into 5 power 4, 5 into 5 power 3. So 5 into 5 power 2. So this 5 power 2 is calculated as 5 into 5 power 1. So there is nothing but 4. So each and every time you are decrementing that exponential values. Okay. In the power values, whatever you have, that you are decrementing, and each and every time you are multiplying that with, that is multiplied with your base value. Okay. So for that here in the main method, up to the power is reached to that, up to the power is reaching to the 0 unit bit, because 5 power 0 is nothing but 1 only. Okay. 5 power 0 is nothing but 1. So like that you need to be. Okay. So for that, here I'm using that function power of. Okay. So here I'm passing that both same parameters, integer A, integer B. So these are the two parameters I have taken, and I'm passing these two parameters as parameter. Okay. First I'm going to be checking that. Okay. For the, I'm going to be checking that if B is exactly 0 or not. If exponent is 0, then you need to be stop that procedure and you need to be written, 1. Okay. In else case, you need to be multiply with A. A is multiplied with which value? Power of, you need to be called repetitively, you need to be called A and then decrement that exponent value. Okay. So A is a, okay. So how you have calculated? So initially, what is the value that we have given? What is the value you have given initially? So now A is given as a 5, B is given as 6. Now 5 and 6 has passed as a parameter. Now A is a 5, B is a 6. Now we are checking that is 6 equal to 0. If it is 0, then you are printing that 1. Otherwise, your 5 is multiplied with your power of 5 comma 6 minus 1. You are calling that 5 comma 5. So that means that here you call this function. Okay, once again the function repetitively called. So now the A value is 5, B value is also 5. Now checking that is 5 is equivalent to 0? No. So in that case, it will go to the else case. In the else case, what here written? A into power of A comma B minus 1. So this entire one is replaced with, okay, 5 into power of A. What is the A value? Base value is not changing. Only exponent values we are changing. 5 minus 1, 4. So that means that you are calling this one. Okay, like that. So each and every time we are decrementing that exponential, that is nothing but b minus 1. So each and every time that is multiplied a with power of that value. Okay, so like that we are calculating. Okay, so that value will be written to that main method. Simply I'm printing that. Okay, so in the main method, I'm trying to print f. Okay, so two value, if you want the directly values, okay, 2 power 3 is like that. I mean printing. Okay, percentage d 2 power 3 is the value. So what is it? 2 means a. What is it? 3 means exponent b. What is the value of power? That is nothing but power of a comma b. That value. We'll close and then semicolon. Okay. So simply I would like to save this code power recursion dot c. Okay. So power of given value. Suppose if I given a simple example, a sample and an easy example. Suppose if I given if I given a value is 2, b value is given as 3, that is nothing but a power b, 2 power 3 you are calculating, that is nothing but 2 into 2 into 2, that is nothing but 2 2s are 4, 4 2s are 8. So you will get the answer called 8. Okay, so we'll check the sample example. So I'm trying to run this code. What is the a value? What is the b value? So a is nothing but base. Base is nothing but 2. Base is nothing but 2. Exponent is nothing but 3. 2 power 3. So simply 8. Okay. 4 power 4. 4 4 are 16. 16 4 are 64. 64 are 256. Okay. For example, if I run that same example, 4 power 4. 256. Okay. So like that we can write recursive functions like that. Okay. This is another example. So when you are writing any recursive functions, you need to be remember the task, you need to be repetitively executing or redoing that same procedure until L number of conditions. In all these cases, we can use recursions. Recursion is nothing but, once again, I'm repeating the definition of recursion. Recursion is defined as a function that call itself to solve a that can solve a smaller version of task. The function that it calls itself is called recursion. It has two conditions or two cases. Okay, it has majorly two cases. One is a base case, second one is recursive case. Base case is nothing but up to which case you need to be do. That is called base case. Recursive case is nothing but repetitively re-executing that until to reach that base case. That case is called recursive case. So in this example, what is the recursive case? This is the recursive case. What is the base case? When b is exactly 0 case, you need to be stopped. That is called base case. Okay. For example, in Fibonacci numbers, what is the base case? When num equal to 0 case or num equal to 1 case, these are the two base cases. Okay. What is the recursive case? Calculating that num minus 1 value and num minus 2 value both are to be added. That is a recursive case. For example, if it is a reverse of a given number, what is the base case? The base case is when num equal to 0 case, you need to be stop and you need to be return that value. That is the base case. What is the recursive case? Each and every time you are going to be calculating that quotient value and finding the reverse of the value. This is a recursive case. Okay. For example, in the previous program, sum of n natural numbers. What is the base case? When num is exactly 1 case, you need to be stopped. That is a base case. What is the recursive case? Each and every time you are adding with num with sum minus 1. This is called recursive case. Okay. And the last one, first program we have seen, factorial. So when num is exactly 1 case, this is a base case. What is the recursive case? Recursive case is nothing but further sub steps. Okay. Okay. So num into factorial of num minus 1. So, okay, how many number of times you need to be called? When num is reached to 1 case, you need to be do that same procedure. That is called sub cases. So these are the sample examples related to that. Simple examples related to the recursive functions. Okay. So I request everyone to cross check all these fragment of codes. Okay. So try to practice and then learn. Still, if you have any doubts, you can ask me. Okay. So that's about the recursion. Any queries? Any questions?